So in this video I am going to explain about the working of this audio crossover unit. In this unit, so this is the main audio crossover unit, this is the audio source, and this is the audio device. So basically it is a real time units which is going to input from an audio file, take its input from an audio file, and then it's going to play it through our speakers or through our earphones. So in this block, as we can see, the output of the audio source is a so the output we can see is of the dimensions 1024 cross 2. So basically nowadays all the audio sources, all the audio files are stereo, which means they have two separate channels. So now the two columns actually stand for the two separate channels. Each column represents a separate channel. Now our first aim would be to separate these two channels. For the separation I have used this multiport selectors, which basically which is in this case splitting the input stereo input into two separate mono outputs, single channel outputs. And what I have done is I have sent each of these channel outputs from the three multiport decoders to a high pass filter, a low pass filter, and a band pass filter. Huh. So then what I have done is I have output the I've included a multiplexer here. So this is I have done this to select the output of each of the each of the frequency components of the input audio mono channel and output it separately. So this is basically a multiplexer which is being controlled by this constant block here. I have also included a provision of being able to listen to the actual mono audio output with all the frequency components present. So this is for that I have used a fourth multiport decoder. Now this multiplexer helps us to switch between the high pass, low pass, and band pass components one at a time. And as you can see, the output of each of these filters is being plotted on the spectrum analyzer, which is the spectrum analyzer 1. Now since I do not have means I am not so for simplicity what I have done is just plotted the other channels on a spectrum analyzer. This is not required though, but ideally in a real system you would also be doing the same with the second channel and then finally combining the two channels and outputting it through different speakers for each of the frequency components. So this is how it works. So next we will be having a look at the simulation output. So the simulation is already running and I am just going to focus on two spectrum analyzers because these are just redundant. They are going to output the same thing. I have just included them so as to see the output, but they are not required. So we will be focusing only on the spectrum analyzer 1 and the spectrum analyzer 3. So as you can see, spectrum analyzer 3 is plotting all the frequency components of the original mono signal, whereas the spectrum analyzer 1 is plotting each of the separate frequency components which have been filtered using the high pass, low pass, and the band pass filters. So this is the output of the spectrum analyzer 1. You can see here the green line represents the output of the low pass filter, the blue line represents the output of the band pass filter, and the red line represents the output of the high pass filter. And the output of the spectrum analyzer 3, you can see the original audio output. So in both the cases you can see that the audio file has frequencies ranging from 0 to 15 kilohertz. So this is all about the simulation. So next we are going to hear each of the separate frequency components and the actual mono channel output, so as to get a feeling of what each of these frequency components separated would sound like. So first I'm going to change this manual switch to take input from the mono channel output. So let's start the simulation. Before that, I'm going to pause my audio. Next, I will switch to the band pass component. So for that, I need to change the constant value to 2. Finally, I am going to change the output to the high pass filter, and you will be hearing the high frequency component of the original audio source. So this was all about the simulation, and this video hopefully gave you an idea of what each of these frequency components felt like. So now I'm going to explain you the MATLAB script I have written to implement the Simulink model we have just discussed. So this might look complicated at first, but let's go through this one by one. Now to implement this MATLAB script, I have used the concept of system objects in MATLAB. If you want to know more about system objects, you can go to the official MATLAB documentation, but here I am just going to give you a rough idea of what a system object is. Basically, it is similar to objects in object oriented programming. So what we have done here, so as you can see, audio file reader, audio device writer, high pass filter, so all of these are classes, and what we have done is instantiated objects of these classes with specific properties. So now let's go through this from the beginning. First, what I have done, as in this case, I had to separate the stereo input into mono output. So that is exactly what I have done here. I have taken in the stereo input and divided into two separate channels and stored them into separate files. L stands for the left channel file, R stands for the right channel file. The naming L and R are just arbitrary. It could have been otherwise. Next, what I have done is I have instantiated an object, audio reader object. So this is basically this object in Simulink model, and I have set the input file name to, I've set the file to swell mono L, and then what I have done, set the output data type to single. So this basically means that it is going to output a single, it is going to have a single output. Next, I have instantiated an object of audio device writer. So this is this block here. This is responsible for outputting the processed audio through your speakers. Next thing is, so here it might get slightly complicated. So this is where the filter design starts. So this is the high pass filter. This is the implementation of the high pass filter using the high pass filter class of the DSP toolbox. Now I have written some specifications here. So these are the filter specifications which are common to all of the three filter blocks I have used here. So you can see here I have used a high pass filter block, I have used a low pass filter block, and a band pass filter block. So these specifications I have defined in the beginning are common to all these three filters. You can see here I have defined two more specifications: pass band frequency and stop band frequency. So these two specifications are specific to this high pass filter object. Similarly, these two specifications are specific to this low pass filter object, and these four specifications are specific to this band pass filter object. And you can see at the end of, after defining each of these filter objects, I have plotted their impulse response as well as their magnitude and frequency response. Similarly, for the low pass filter and also for the band pass filter. Next, what I have done is instantiated an object of this spectrum analyzer class. So these are basically these blocks. So as I told you in the beginning, not all of these spectrum analyzers are absolutely essential. They are just there. But the two most important, but this one is the most important because it helps us visualize the separate frequency components. So that's why I have instantiated just one object of this class, but if you want, you can do more. So next, what I have done is, in a while loop, I have taken in the audio stored in this variable audio, and then I have applied the high pass filter, low pass filter, and the band pass filters to this input audio, and then finally I have sent the outputs of these three filters to the spectrum analyzer. So this is basically all these steps are basically defining the interconnections in this Simulink model. And this while loop, while not is done audio in, this basically means that it needs to run until and unless unless we have streamed the entire audio file. So this is all about the MATLAB script.